Hello, physics students. In order to solve this second problem, we are going to take a close look at the path because it's asking about the maximum height that the ball gets to after it's launched 20 meters per second at an angle of 35 degrees. From our previous problem, we already broke that vector into its components for both the horizontal and a vertical velocity. For this one, we were going to focus on the y direction, and we're going to make a new list that helps us understand what's happening to that vertical velocity and about the time that the ball is when it's halfway to the top of its path. So a couple key ideas to keep in mind. The time to the top part of the path is 1/2 of the total time. We already figured out the total time in our previous problem was 2.3 seconds. So I can divide to find the time by 2, and that will tell me how much time it is at the very peak, which is its maximum height. The second key idea is that the vertical velocity at the top is 0. So it starts at positive 11.5, and because gravity is accelerating it, it will decrease as it travels to the top, and it will be 0 at the very top. So we can think of that as a final velocity. So I have two new values that I can work with. I can say that the final velocity at the top is 0, and I can divide my time by 2, giving me 1.15 seconds. So the time to the top is 1.15 in this example. Now I can choose any equation that has these variables and can solve for my missing vertical distance. So I really want to find out how far off the ground it is at its maximum height, which is a dy. Here's an equation that solves for dy, 1/2 viy plus vfy times t, and I have all these variables. Substituting in 0 for my final velocity, I get 1/2 times 11.5 times 1.15 seconds. Then I can solve this and I end up with about 6.6 meters. So that becomes my vertical distance. We might consider also solving it with this equation, where the vi times t plus 1/2 gt squared is also the vertical distance. This equation takes into account that my initial velocity is positive and the time is 1.15 and my acceleration is a negative. So these two terms actually end up subtracting and I get the same answer. A lot of times in kinematics, you'll find that the same answer is something that works for both.